This is Tokyo, the most populated city in the world. Home to top-rated restaurants, beautiful temples, and over 37 million people. Now it's adding another landmark to its list, a super-tall skyscraper that's built to withstand earthquakes. At 330 metres, the excitingly named main tower will be the tallest skyscraper ever constructed in Japan. Now, while earthquake-resistant towers aren't new, Tokyo is one of the toughest places to build them. Disaster-proofing its infrastructure is quite literally a matter of life and death.
Next to Japan, where a magnitude 6.1 earthquake has struck Tokyo today.
A powerful earthquake measuring 5.9 in magnitude.
Many homes in Tokyo have lost power.
8.9 magnitude. It was the fifth largest earthquake in history.
As Tokyo's buildings get taller, the challenge of ensuring their safety gets harder. And the recent disaster in Turkey and Syria has been a horrific reminder of the devastation that can unfold when buildings collapse. So what exactly goes into building the tallest skyscraper in a city where earthquakes are more common than anywhere else? And what makes this new development different from all the rest? Before we get onto this cool building, you need a bit of context. Japan may be known for its cuisine and bullet trains, but earthquakes are also one of its most common occurrences. In fact, thousands of minor quakes are recorded each year. Most go unnoticed, but the fact is the country sits in one of the most seismically active zones in the entire world. Tokyo itself sits right along what's known as the Pacific Ring of Fire. No, that's not the drinking game you played at uni. Scientifically speaking, the Ring of Fire is a zone where several of the Earth's continental and oceanic plates meet. In very simple terms, when the plates suddenly break or become displaced along those lines, an earthquake or volcanic activity occurs.
We are getting a clearer picture today of the destruction from Friday's earthquake, which Japan now says was a magnitude 9.
One of the strongest ever in Japan happened back in 2011. A magnitude 9 earthquake shook the area, later resulting in a tsunami. Both events destroyed thousands of buildings across the country, and even a nuclear reactor. With such frequent activity, Tokyo's buildings are all built to withstand earthquakes as best they can. It's complicated, so we asked an expert, who quite frankly knows a lot more about this than I do, to explain.
We don't actually design to a particular magnitude. We design to an acceleration. So we look at the level of acceleration we're going to get from the largest earthquakes in the region and use that in our calculations. You've got the mass of the building, you've got the acceleration of the earthquake, and that gives you the lateral load on the building. And that's a very simplistic way of looking at how we come up with a load to apply to the building.
And since 2011, building codes and technology have been strengthened even further. Because of all this history and those recent regs, the city hasn't built many tall skyscrapers and absolutely no super talls. That is, a building over 300 metres. Now, we're just talking about official skyscrapers here, not structures like the Skytree, which is obviously much taller but is classed differently to a building. More about that on our website. The current tallest building in Tokyo stands 255 metres above the city, but that's all about to change. Coming your way in 2023 is the main tower, which recently tops out. With 4 curved glass petals around its roof, the building is designed with a column-free open floor plan inside. It'll stand on a new urban development called the Toranomon Azabudi Project, or officially the Azabudi Hills, along with 2 other buildings called the East and West Towers. Seriously, work on the naming. The 8-hectare district includes ample green space, businesses, shops, and residential properties. And to remain sustainable, 100% of the supplied electricity will come from renewable sources. In total, the whole project aims to create a kind of city within a city. More importantly, those 3 main structures will be earthquake resistant and serve as a place where up to 3,600 residents can flee to during a major natural disaster, even if a quake as strong as 2011 hits. But it won't just be a temporary place of shelter. The development is structured so businesses and life can carry on in the event that other areas are destroyed. Now, it's a special kind of line manager that asks you to keep working through an earthquake, but you get the idea.
If you could just go ahead and make sure you do that from now on, that would be great.
Now, real estate in big cities is normally a reliable investment, but these are not normal times. Just look to the US, where the New York market recently hit its lowest level since the 2008 financial crisis. Everyday Americans are feeling it too. The majority of people making six figures now live paycheck to paycheck, and a third of US households relied on credit cards to cover the cost of living in December. The way people invest is changing too. The typical stock-bond strategy lost an average of 25% last year. But experts found that when inflation is high, real assets like art can perform better than real estate and stocks. That's where Masterworks comes in. It lets you invest in high-value art from icons like Picasso and Banksy for a fraction of the full price. And despite record losses in global markets, Masterworks has sold 11 paintings, each of them returning a profit. There's a waitlist to join their more than 630,000 members, but you can skip it right now at the link below. Building an earthquake-resistant new area complete with skyscrapers would likely rattle most engineers. As the buildings get taller, so the stakes rise.
It needs a vertical system that can take the gravity weight of the building, and then it needs a secondary system that can accommodate the lateral loads. And buildings all around the world, be it in an earthquake zone or non-earthquake zone, have to accommodate for wind loading. If we're in an earthquake zone, we then also additionally have a lateral load, but it's a cyclic load, so it's one that's going backwards and forwards. And if we think of an analogy of a safety pin, if you twist that backwards and forwards, you do it too many times, eventually it'll break. So we need to ensure that we're never in a situation where it will break, and ensuring that the building doesn't collapse.
But Japan knows how to take on the challenge. In all the towers, high-strength steel and concrete components will be used throughout, along with efficiently located vibration control devices that help to reduce shaking. One of these is a weighted device called the Active Mass Damper. It sits near the top of the building and will help reduce swaying due to high winds or shakes. But disaster-proofing a Supertall takes more than just one giant damper. Other small components are also strategically placed throughout the building. Here's how they'll work. First up, we have oil dampers, mechanical devices that operate by using the fluid resistance of the substance to absorb vibrations. Then there's viscous wall dampers. These use the resistance of a material with high viscosity, which in very simple terms means how much a liquid or gas can resist changes to its shape, to absorb any movement. Finally, there's unbonded brace dampers, pieces of stretchable steel that can absorb some of the energy from an earthquake. But reducing vibration isn't the only thing engineers have to consider. While these measures will save people's lives during a seismic event, the aftermath matters too. Because disasters tend to knock out power, the Toranomon Azabudi district has come up with a way to keep it running. A cogeneration system will be installed in the basement of the main tower. It'll be resistant to any source disruption, allowing the tower to supply electricity to the entire development for up to 72 hours. This could mean the daily lives of residents continuing with little interruption, and that's key, because this whole project has been heavily designed around its occupants. Architectural planning started by outlining the flow of people around a central square. Locations for the buildings were secondary. And by building taller and more compact skyscrapers, the Toranomon Azabudi district is able to maximise green space and design necessities to be located within walkable distances. Its goal is to create spaces where residents can easily connect with each other. Now, Japan has previously used compact cities like these outside of Tokyo as an attempt at economic revitalization. Toyama pushed this concept by renovating public transport, revitalizing its downtown, and creating a walkable city. The developers behind Toranomon Azabudi say they're out to create a place that people can escape to rather than flee from. And if their main tower is a success, then perhaps the wider country will continue to build taller in the years ahead. Last week's devastating events in Turkey and Syria are a powerful reminder of the faith we place in the engineers and construction teams who create our built environment every day. Where things do go wrong, it's important that we thoroughly investigate, establish the facts, hold people to account, and learn for future developments. We started producing this video long before the Turkey-Syria earthquake struck, and our thoughts are with everyone affected by the disaster. We'd encourage you to make a donation to Direct Relief at the link below. You can learn more about Tokyo's new Supertall skyscraper and the other topics on our channel over on the World's Best Construction podcast, available right now wherever you get your podcasts. And as always, if you enjoyed this video and you want to get more from the definitive video channel for construction, make sure you're subscribed to the B1M.